let's explain the PIA. So here's a little drawing or repetition. We want to make a yard, like a garden, and we want to make it in between a river. So we want to have the maximum area of it with a material of 100 meters. So what we want to do is have two problems, the maximum problems we can have here. So in this place we can have the area and the perimeter. The area is x multiplying y, and the perimeter is 2y plus x.
Now, let's take all that was said previously into account and think of it in a more thorough context. Imagine the following. A farmer wants to build a rectangular fence next to the river, as shown in the illustration to the right. The side by the river won't occupy fencing due to it being open because of the river's presence. It is known that the farmer has 100 meters of wire mesh to use in said fence. What should be the dimensions of the fence so that the area is as maximized as it can be? We know we have two smaller sides, the x variable, and one large side, the y variable. We know from the farmer's limited fence that the sum of all sides available will be equal to 100 meters of wire mesh. This can be represented through the equation 2x plus y equals to 100. Why is the other y not accounted for, you may ask? That is simple. It is said in the problem that it is not accounted for due to it being by the riverside. But to find the most optimized way of it is its own thing. We know we have two smaller sides, the x variable, and one larger side, the y variable, which when summed equal to 100. And the area itself will always be the multiplication of x times y, which is a times y.
We know the problem, that is that a farmer wants to put a rectangular fence next to the river. So we know that a rectangle have two smaller sides and two long sides. So we will we know that the sum of these will give us 100. So we first have to make the equation, which is 2x plus y equals 100. And to find one variable, we have to isolate one. So in this case we will isolate y, and this will give us 100 minus 2x. We also know that the formula to find the area of a rectangle is x by y. So we already have y, so we are gonna substitute. And instead of putting the y, we'll put 100 minus 2x. So we will have x by 100 minus 2x. And if we simplify this, it will give us 2x squared minus 100x. And this will give us all the area that we want to find of the rectangle.
After using the formula to isolate y, we have to replace values. Using the formula of the area, which is represented by the a, with the prior value of y obtained, it would be a equals 100 minus 2x times x, which equals to 100x minus 2x squared.
For this case, we are trying to find the local maximum of a in function of y. For that, we have to have the derivative of the function and equal it to 0 to find the value of x. If we put the values in the function, it will become a derivative of y equals to 100 minus 4x. That turns to 100 minus 4x minus 0. And after that, it's going to become x equals to 100 over 4, and that gives us 25. That will be our critical point. So let's test our answers in order to see if the function will be increasing or decreasing. With the use of the derivative test, we shall see if we are able to confirm our beliefs of these being the right values of x. we guarantee that 25 will get us the highest values possible. So let's put the intervals. The first intervals are 0 and 25. We are going to choose the 15. So that will give us 40. That means that the function will start increasing. And if we go to the second intervals that are 25 and 0, we are going to choose the 30. That will give us minus 20. And it will say that our function will end decreasing. In one moment, I'm going to show how the graph is going to be. Okay, so if we put the y in here, and in here we put the area, that it means that is a function of y, and in the middle of the y we put the 25. And we use the values of our table that they said that the graph it first starts increasing, and in here in this point of the 25 it starts decreasing. On that point that it starts decreasing, it's the local maximum, which means that the value that is going to be in the middle of the garden, the area, is going to be the highest value possible.
Hi, today I'm going to show you a real-world problem using a whiteboard. Imagine you're a farmer and you want to build a fence next to a river. The river already forms one side of the fence, so you only need to use fencing for 3 sides, 2 widths and 1 length. Let's say you only have 100 meters of fencing. And the challenge is to figure out what shape gives you the biggest area inside the fence.
So, how do we know which shape gives us the maximum area? We could keep testing shapes forever, but this would take a really long time. Or we could use calculus. Calculus lets us take this situation and create an equation to find the exact dimensions that give the most space. This is a great example of how math helps solve real-world problems, especially when we have limited resources like fencing. With a clear model like this, we can understand the problem visually and then use calculus to find the best solution.